So today we're going to talk about the commutative property of addition. The commutative property of addition. So we're going to say the commutative property of addition. Okay. The commutative property of addition states that the order in which you add two numbers doesn't affect the sum. So the commutative property of addition states that the order. We're going to say the order, yep. In which you add two numbers doesn't affect the sum. All right. The commutative property of addition states that the order in which you add two numbers doesn't affect the sum. Okay, so what does that look like? The commutative property of addition states that the order in which you add two numbers doesn't affect the sum. That means that if you have 2 plus 3 and you have 3 plus 2, the order, it doesn't matter. It doesn't affect the sum. The sum is the answer to the addition problem. So 2 plus 3 is 5, and 3 plus 2 is 5. So the commutative property of addition states that the order in which you add two numbers doesn't affect the sum. You could flip-flop. We can call it a flip-flop, or you could turn around. You could turn around those numbers, but it doesn't affect the sum. The sum will stay the same. Okay? So let's try that and see how that works. Give me two numbers. Any two numbers that you want to give me. 5
and 7.
Okay, so 5 plus 7 is equal to 5 plus 7, right?
Mm-hmm.
But what if I flip-flopped or I changed those numbers around? What would it look like then? 5 plus 7 is equal to what?
7 plus 5.
7 plus 5. What is 5 plus 7?
12.
All righty. And what is 7 plus 5?
12.
12. So let's look at this. The commutative property of addition states that the order in which you add two numbers doesn't affect the sum. It doesn't affect the answer to that addition problem. Let's try some other numbers. All righty. Let's try other numbers. Okay. May I have two different numbers?
6.
All right. So let's have a 6
7.
and 7. 6, 7 is 6, 7, right? 6 plus 7 is equal to 6 plus 7. 6 plus 7 is equal to, how do I flip-flop those numbers?
7 plus 6.
7 plus 6. And what is 6 plus 7?
13.
Very good. And what is 7 plus 6?
13.
Very good. So, there we go. The commutative property of addition states that the order in which you add two numbers doesn't affect the sum. 6 plus 7 is 13. 7 plus 6 is 13. So let's try some more numbers to see, just to practice that. May I have numbers, please?
5
Uh-huh.
and 2.
Okay, is equal to what?
7.
Okay, but we're trying to practice this commutative property. So I want to do the same thing, but I want to switch the order. So 5 plus 2 is equal to?
2 plus 5.
2 plus 5. So we already know, because we've tried it out, we've proven it. We already know that 5 plus 2 is equal to 2 plus 5. Because that's what this commutative property of addition states. It states what? That what?
That it doesn't affect the sum.
Yeah, that the order in which you add two numbers doesn't affect the sum. May I have some more numbers, please?
3
Uh-huh.
and 7.
3 plus 7 is equal to?
7 plus 3.
7 plus 3. Okay, more?
Other numbers?
Yeah.
8
Uh-huh.
and 2.
8 and 2 is equal to?
2 plus 8.
2 plus 8. All right. So let's read this together. The commutative property of addition states, come on, that the order in which you add two numbers doesn't affect the sum. All right. I want you to give me a few more numbers and then I'll come up with some numbers. Okay.
2 and 4.
2 plus 4 is equal to?
6.
Okay, it is equal to 6, but we want to apply this property here. The commutative property of addition states that the order in which you add two numbers doesn't affect the sum. So 2 plus 4 is 6, but what else is equal to 6?
4 plus 2.
4 plus 2. Those are sum. This sum is equal to this sum. The order does not change. The order in which two numbers that are added together, the sum doesn't change. Okay? So let's see this. Let's do this one. What is 3.5 plus 2 when we look at the commutative property of addition? What else would this look like? 3.5 plus 2 is equal to?
2
Uh-huh.
plus
Yes.
3
Uh-huh.
and a half.
Right. 3.5. Okay, what's 7 1/3 plus 5.5? What is that equal to?
5
Uh-huh.
and a half
Okay.
plus 7 and a half.
Oh, that wouldn't be equal. So we got to really keep our eyes on there on the board, because 5.5 is equal to what? This says 7 1/3 plus 5.5 is equal to 5.5 plus what?
7 1/3.
7 1/3. Right. Now it's equal. Okay. So let's try some more. Ready? What about 5 2/10 plus 3 7/10? What is that equal to?
5 2/10.
Uh-huh. 5 2/10 plus 3 7/10 is equal to what?
3 7/10.
3 7/10.
And 5 2/10.
Yes, plus 5 2/10. What about this one? 3 7/10 plus 6 40/100. What is that equal to? 3 7/10 plus 6 40/100. What is that equal to based on the commutative property of addition?
6
Uh-huh.
and 40
40 what?
tenths.
Hundredths. Hundredths. Plus what?
3
Uh-huh.
and 7 ones.
7/10. That's 7/10. Very good. Okay, read that with me. 3 and 7/10
3 and 7 tenths.
plus 6 and 40 hundredths
Plus 6 and 40 hundredths
equals
equals
6 and 40 hundredths
6 and 40 hundredths
plus 3 and 7/10.
plus 3 and 7 tenths.
Very good. All right, I need you to stay here. All right, let's do this one. 6 and 375 thousandths plus 4 and 251 thousandths is equal to
4 and 2,051 plus 6 and 3,075.
okay, you read the number. So this is 251, right?
Mhm.
So you say 4 and
4
251
251
thousandths.
thousandths.
Okay, so 4, let's go with this one. 4 and 251 thousandths plus 6 and 375 thousandths. That side is equal to that side, right?
Yep.
Yeah. How do you know that? Because what?
Because the commutative property of addition states that the order in which you add two numbers doesn't affect the sum.
It doesn't affect the sum. It never will affect the sum. It's going to be the same. The answer will be the same whether I have the 200, whether I have the 5 and 2/10 plus 3 and 7/10. Switch it around, switcheroo. 3 and 7/10 plus 5 and 2/10. They're the same. They're equal. Okay? So thank you. You did a great job. And let's read this together because we just learned that what? The commutative property of addition states that the order in which you add two numbers doesn't affect the sum. Very good.